Most human problem-solving relies on a cognitive shortcut called reasoning by analogy. We look at a solution that already exists and try to replicate it. This process is efficient, but it limits us to slight variations on existing themes. You might change the color or the branding, but the core mechanics of the problem remain untouched. But analogy is useless when the scale of the problem is total. You cannot rely on minor iterations to solve for the collapse of an ice shelf or the depletion of planetary resources. Before 2008, the consensus across the aerospace and automotive sectors was that the numbers didn't add up. The raw cost of materials and manufacturing made electric vehicles and private space travel economically impossible. Solving these specific, large-scale challenges requires abandoning the mental framework that most people use to navigate their daily lives. In 2008, the global economy faced its largest contraction in 80 years. At the same time, Elon Musk was watching his $175 million fortune from the sale of PayPal disappear. He had invested almost all of it into two startups, Tesla and SpaceX, industries that experts said were designed to fail. By December, both companies were on the verge of bankruptcy. Musk was borrowing money for rent while trying to keep two high-burn engineering teams functional. To the outside world, his persistence looked like a lack of realism. Critics labeled his business plans as mathematically insane. But his survival wasn't based on a hunch. It was the result of a specific logical framework that allowed him to see a path where others saw a dead end. That framework is called first principles thinking. It involves stripping a problem down to its most basic physical and material constraints and then building a solution back up from that foundation. This habit began in Pretoria, South Africa. Growing up in a violent and unpredictable household, Musk turned to technical manuals and encyclopedias to find answers that were based on logic rather than emotion. Physics and computer code provided a sense of control. If he could understand the foundational rules of how a system worked, he could predict and eventually build new outcomes. When he arrived in Silicon Valley in 1995, he applied this same logic to his first software companies. By focusing on the basic requirements of the internet and banking, he built Zip2 and the platform that would eventually become PayPal. For Musk, first principles isn't just a business strategy. It is a tool used to navigate a world that often relies on flawed assumptions. Take the battery pack in an electric car. Reasoning by analogy tells you that because battery packs have historically cost $600 per kilowatt hour, they will always be too expensive for the mass market. A first principles approach asks, what is the battery actually made of? You break it down into raw elements: carbon, nickel, aluminum, and steel. By market exchange value, those materials cost only $80 per kilowatt hour. The remaining $520 is simply the cost of how those materials are currently combined. That is an engineering problem, not a physical law. This reliance on material facts gave him the conviction to continue after 3 consecutive SpaceX rockets failed to reach orbit, costing the company millions. On the 4th launch, the Falcon 1 reached orbit. This success led to a critical $1.6 billion NASA contract on Christmas Eve, which provided the capital to save both SpaceX and Tesla. When you have mathematically proven that the physics of a project are sound, even a series of catastrophic failures is viewed as a temporary engineering hurdle. By applying this logic, Musk turned the impossible into a physical reality. Today, electric vehicles and reusable orbital rockets are moving through automated assembly lines. His companies now function as a set of interlinked tools. Tesla provides sustainable energy, SpaceX provides transport, Starlink handles global communication. They are designed to work together to address the material requirements of a multiplanetary society. But reconstructing solutions from the ground up requires an immense expenditure of effort. There is no existing map to follow. This process resulted in 120-hour workweeks, years of litigation, and the collapse of personal relationships. Developing the tools for a different future requires a total sacrifice of personal comfort. Major technological breakthroughs are rarely the result of minor adjustments to existing models. True innovation requires moving past what everyone else is doing and re-examining the problem from its most basic elements. To build something that has never existed, you have to start by breaking the world down to what is physically and mathematically